Okay, let's get started. Okay, hey everyone, thanks for joining. So yeah, this is the second session. We did a session last weekend, I believe, on how to create a portfolio, including how to create a README file on GitHub. So we're gonna continue that for next couple of weeks. So today we'll do a project on computer vision. So how to do object detection. And then we'll see how to update that on your portfolio. So today's session will be mostly by Shit, and I'm going to walk you through how to update the portfolio either at the end, or we'll do that in the next session. And if you guys have any questions or anything, feel free to just interrupt or put in the chat. So let me just give you a brief info, and then I'll let Ashit take over. All right, wrong ones. Okay, can you guys see my screen?
Yeah.
Okay. Okay, so for people who don't know us, so we are Data Reproduction. Started by me and Ashit a few months ago. So it's mostly, started this mostly for podcast series, and then teach end-to-end projects to beginners as well as to professional data scientists who don't usually do end-to-end stuff at their work, but they want to upgrade themselves. And also master classes that we offer for free, such as the one that we are doing today. Ashit, do you want to introduce yourself quickly?
Yeah. So hi everyone. This is Ashit. For those of you who are joining the first time, so I'm currently working as a data scientist, senior manager at IDFC First, and yeah, feel free to connect with me on LinkedIn.
Me, so I work as a data scientist at Decathlon, Canada, and you can connect with me on LinkedIn as well. And then other than that, I just want to give you a brief info. So we have a website that you can go check it out. You'll find some useful resources. So if you go here, you'll find more about the end-to-end mentorship program, as well as this documentation here. So if you are new to GitHub and all that, you can go check it out to learn about GitHub, how to set up content environment, Python, all that stuff. Okay, so let's jump right into today's project. I'll let Ashit take over.
Yeah. Okay. Is it visible?
Yeah.
Yeah. So Mithil, just keep admitting the people who are coming. So anyone who already knows what is object detection? Anyone here? You can either put it in the chat or raise your hand. So Manoj has used OpenCV before. Okay. So OpenCV is used for a lot of things. So what did you use it for? Okay. So, right. Detecting objects in an image or a video, right? So yeah, that's exactly it. Basically, you have an image and you want to detect what all objects are there in the image, or what all objects are present there in the image. And what about a video? So video is nothing but a series of images, right? So whenever a series of images start shuffling through very quickly, it seems like a video to us. right? And along with some audio as well. So this is object detection. So how can we go about training such a model? Anyone has any ideas? So basically, the problem statement is this. Let's say you have a list of 10 objects that you want to detect from an image. And you have some training data where you have, let's say, 10,000 images where uh, whenever those objects appear, you have the location of those objects. So let's say you have a bounding box of the object. So for example, this image, this is the car, and this red rectangle is the bounding box of this car. So you have such a data. Now, any ideas how we can train a model for this? Anyone? So even if you don't know, you can give it a try. Right. So Purnima says, Alice says, by feeding model with a lot of similar object images. Uh, so, so if you train a model, so basically you have to first define for a model what is the input and what is the output, right? So you have to define what is going to be the output for this model. So you can't just feed a model with a lot of images and expect it to do something. So you have to define what is the output first. Purnima is saying training the model with similar images. Yes, the same thing again. Kritika is saying we will give labels. Yeah, right. So what kind of labels are these? Because this is not a normal like linear regression problem or a classification problem where you have a single output that you can train on. Here you have your image is a 2D matrix, right? Also, if the image is colored, it is a 3D matrix. And output you need is, let's say, you need two outputs. You need a bounding box on the object, and you need the confidence score. Manoj is saying image pixels. Yeah, that is your input, right? So anyways, let's Sanjeevni is saying, I guess we will use clustering. Okay. So we'll see how we can train a model on this. So there's a model called YOLO. We'll see how to use that. So let's first get a data set, right? And see what the data set is all about. So everyone, you can even open this by yourself. So I'll just show it to you. Mithul, this tab is visible, right? This dataset tab.
Yep. And I'm gonna put the link in the chat if people. Okay, actually, that's already done it. So I encourage everyone to try it with us. So you can open your Google Colab, and then basically just code along with us. It's not a lot of code, so you'll get through it.
So Kritika, can we use CNN? Yeah, YOLO is completely based on CNN. So yeah, we will be using it. So it only makes sense to use CNN for images, right? Because it is actually like meant for CNN is actually meant for matrices. So that's why. So you can if you can see this data set. So what is this data set? It is basically images of vehicles and there's a bounding box on them. So wherever is the object, we know where is the object. The training set has about 4,000 images. Validation is 200. Testing is 150. So we are going to be training a YOLO V7 model, right? So you just click on it, show download code, continue, and it will give this code to you. you can go ahead and copy this, right? I'll just show you how to use this in a bit. So first I'll just explain what exactly is YOLO, right? So what is YOLO? Yeah, so what is YOLO? YOLO is a single shot detector that uses a fully connected CNN to process an image. So if you have studied object detection before, you might have used like multiple shot detections and not single shot detection. So mostly the other models, if you study them, they'll have to look at an image multiple times to detect an object. But with YOLO, it just looks at the image once, and then it is able to detect the object. So the full form of YOLO is you only look once. So that is kind of the definition of it. It is a single shot detector. Now, it is an end-to-end neural network that makes predictions of bounding boxes and class probabilities all at once. So we are predicting two things. One, the bounding box, and the other thing is the confidence score. Sabari is asking which YOLO version. So now today we'll use YOLO V7. So it differs from the approach taken by previous object detection algorithms, which repurpose classifiers to perform detection. So here we are not really using a simple classifier to detect. Now, what's next? Right, so we'll just directly jump onto the code. So Mithul, can you put these links in the chat?
And if you guys want to follow along, if you're following along, and if you want us to pause or go slow, let us know. So we'll do hand in hand together. So I'll put the links in the chat. Sarah, there are really good articles out there. So we're just providing you the links. If you wanna go ahead and read those in detail, you can go check it out. So that's the link for the article. And then there's a Google Colab. Is this public, the Google Colab? Or
yeah.
Okay. So I'm putting the link in the chat. You can also go check it out, the Google Colab. And then the data, we don't have the data yet. Yeah, you can go get the data from the website that I should show you earlier. I think
the model, the drive link is
that's a model, right? Okay. I think you need to sign up on the website before you can use their API. So if you haven't done so, you can go sign up.
So first of all, you can open this Colab notebook using the link in the chat. And when you connect to a runtime, make sure you switch to a GPU. So a GPU should be visible here. So like a GPU RAM. How do you switch? You go to runtime, change runtime type. Then hardware accelerator is, you choose GPU. TPU mostly won't be available. So just use a GPU. GPU type can be T4. So once you connect to a GPU, you'll be able to see this GPU RAM over here in this section, resources section. Now let's see what we are doing. So first of all, we are cloning the YOLO V7 repo. So it has all the codes for training and prediction. So we just clone it, and inside this, there's a requirements file. I'll just install all the requirements. So it is done. I've already done that. Now this code that you copied from here, right? So just copy it and put it in this cell. So this API key, this will be unique to your account. So just use that one. So it will automatically appear in your code. So you don't need to change anything once you copy it from here. Once you do that, run that, you will actually get the data set with you. And then you just have to run this code. Okay, so what is this code? So we have a train.py file, which is inside YOLO V7 folder. So what I'm doing here is I'm just going inside the YOLO V7 folder. So that is my working directory now after this. Then you can see there's this train.py here. What does it do? It allows you to train your model. So it takes in some arguments. So what is the batch size? The number of epochs? Where's the data set? So the data set will contain a YAML file. So we can check that as well. So dataset.location is vehicles 2. This one will have a YAML file. What it has is it has all the classes. So this data set is containing 5 classes. This is sort of garbage. There are mainly 4 classes: bus, motorcycle, car, and truck. When you train on this data set, the model should be able to predict these 4 vehicles at least. Then this is all. This is not of use to us. We'll leave it here. Here is the location of the images and the labels. So test images. So let's just see the train images. So it is in the train folder in the images. So these are the images. Let's just check one of them. So this is an image. It clearly has a car, and in the labels folder, there'll be the information of its bounding box. So if you just open this, one of the labels, so here you have 5 values. What is this 3? 3 is the class number. Which class it is this? So 3 is basically this car. 0, 1, 2, 3. It starts from 0, goes till 4. So we are saying that this image has a car. And where is the car? We're also telling that the car is bounded by this box. So basically, this is the first point x comma y, second point x comma y. These are the diagonal points. So we have all the data set in this format. Then we can just see and train this model and see how it goes. Anyone has any questions till here?
So if you guys are following us, let us know if you're up to this point. Is there anyone there who's coding along with us? So if you guys are coding with us, you can put in the chat that you are coding with us so we can go slow.
Actually, you don't have to code much. So we have already given you the
Yeah, there's not a lot of code. Okay, good. The good thing about YOLO is that you get rid of a lot of lines of code that you have to write yourself, right? So if you were to do the standard, let's say classification or something like that, you have to either you can build the CNN from scratch, or even if you use the pre-trained algorithms, you still have to train the top layers, and you have to code, right? You have to do data augmentation and all that stuff, right? The thing with the YOLO is that it takes care of all of that underneath of it. You can go ahead and pass in, I think, additional parameters for those kind of things. But yeah, the object detection takes longer than just doing a classification, right? So here in the notebook, you'll see that we have used the batch size of 16 and epoch 1. We use epoch 1 because we were trying to see how long it takes just to train one epoch. I think I should trained earlier for 55 epochs, and it took a really long time. Even with one epoch, it takes about 10 to 15 minutes. So yeah, I'll let you guys decide for how long you guys want to train it for.
Right. So we saw I think one epoch takes about 5 to 10 minutes, depending on the GPU utilization, and so we are just seeing whether it is training or not. So we are just doing it for one epoch. Batch size 16. This you can vary by yourself. The weights. So basically, these are the initial weights that you want to start with. You can anyway start with random weights, but YOLO V7 repo already gives us with some initial weights, so that the training can be faster. So if you see in this train, so I'll just run this and let it run. So this will only run for one epoch. So let's see how long it takes. So if you see in the train.py, there are so many of these parameters, these arguments that you can vary. These are the weights. So like what are the initial weights? So you can always see, refer this help thing. So it describes what this argument is for. This CFG parameters probably stands for configuration model.yml path. So basically an initial configuration of the model. This data, where's the data set, right? So it looks for the data.yml file and so on. These hyperparameters, epochs, batch size, image size, so on. You can tweak these, but right now we won't tweak any of these. We'll just use the necessary ones. So as you can see right here, it is training. 0th epoch is going on. If you can see the GPU utilization, it is already reached up to 13 GB out of the 15 GBs. So let's see. I think it should take 4 or 5 minutes. So until then, anyone has any questions? Any fundamental doubts? Like what are we doing here? What is Colab? Anything like that? Everyone has worked on Google Colab before? Anyone who has not worked on it? So Kritika is asking, can we integrate YOLO trained model with Android? Yes, you can. So as long as you have a machine, right? So you can run a model on it. So what do you need to run a model? You need computing power, right? Your Android phone has computational power. You can host it on that. Just that you have to see. So for example, Android probably uses Java to write the code. So you have to see how do you load the model in Java. So the model that we are training, it comes in a .pt format. So that is like a standard PyTorch format. So it needs metadata with TensorFlow Lite model. So how to add metadata to YOLO model? What do you mean by this metadata? Sanjeevani is asking, can we use YOLO to convert image to text? No, you can't. YOLO is only an object detection model. You can't do image to text. Image to text is more of a generative model, right? So YOLO is not a generative model.
It's like one thing we could do is like embedding kind of thing. So like there are companies who use object detections and all those sort of algorithms to just detect something. And then on top of that, we use maybe NLP algorithms or something to convert it to text or all the NLP related stuff.
You need something along with this. So alone, you can't do anything. In order to integrate YOLO model with Android, we need to convert it to TF. But then it also needs metadata, labels, and other info. So the labels, if you need the labels, so I'm not sure about the other info, but the labels you already have, right? So I think by labels, you just mean all the classes that the model is trained on. So that is there in the data.yml file. So also this model is not a TensorFlow model. This is a PyTorch model.
So if you're mainly like want to know about the deployment part, so I think once you train the model, you just need the model, right? You don't need anything else other than the classes that the model is trained for, right? So, I mean, in terms of deployment on Androids, I'm not aware of that, but
So the
the way that
PT
we put it,
file already has every information that it needs to go
Okay.
like all alone.
Yeah, today we are going to deploy it on AWS. So there's a Streamlit app that runs on AWS, right? So that's how we have deployed it.
So one epoch is done.
So
Took 4 minutes 42 seconds for one epoch with the GPU. If you do it on a normal CPU, it will take, I think, 10 times more time. So you can see whenever your model is trained, so it saves the model in two ways. So this is something called last.pt. So what is this? This is the model at the last epoch. Whatever the last epoch was, after that it saves the model. And this is best.pt. So however many epochs have been done, which model was the best among them. So this that model is saved in best.pt. Here both are the same because we have only done one epoch. So we can pick any of them. So where is it? It tells you where it is. Runs, train, exp2. So runs, train, exp2, waits. So there is this best.pt, last.pt, init.pt. This is the initial model before training started. And this probably is after the 0th epoch. So that is also the same. No, it is not the same. The size is really different. I'm not sure what is this. So make sure to choose the best.pt model because that is the best model our training has encountered across the epochs. So how do you define a best model? So basically it is the best model on the parameters that you are training on. So whatever evaluation metric you are optimizing on, so that is optimized the best in the best.pt model. What you can see here is F1 curve, precision recall curve, precision curve, recall curve. Let's see what is this. I hope everyone knows what is F1 score. So F1 curve gives you the F1 scores for all the classes that the model is trained for. So for example, this is for the bus, this orange one. This is very bad. So you can see different metrics. So this is precision recall curve. So this green one looks very nice. So this is the motorcycle. So this so in one epoch, the motorcycle class has been trained very well comparatively. Not absolutely, but comparatively compared to the other classes. For the all classes, this is the dark blue line. So this is not a very good model, but still I think decent enough. Just in one epoch. So I've already trained this model for 55 epochs before. So I'll just give you that model so that you can use that directly. Or if you don't want to use that, so just keep training this model for however many epochs you want, right? This is the precision curve, this is the recall curve, and so on. It gives you the confusion matrix. So here you can see none of the classes are trained very well, right? So yeah, so this model is really bad. So that's why Method has put in a link in the chat. We'll just use that model to predict. So what you can do is you can just keep training it for more epochs. So just change this number here. So here you can put 100. So it will take a lot of time. So 100 epochs will take 500 minutes. So you can keep training that, and you can use the best model after that. So you can download our model from the link in the chat. And what I've done is I have put it on S3. So where is my S3? Also keep asking any doubts you have, everyone. So I'm sure whatever I'm saying is not very clear to some of you. So please ask, keep asking questions so we can keep clearing it. So this is S3. Anyone here doesn't know what S3 is? Or anyone would like to tell what is S3? Okay, so Suhana doesn't know. So I'll just explain it once. So what is S3? S3 stands for Simple Storage Service. So it is basically, so you know Google Drive, right? So it is a cloud server where you can store some files. So S3 is a kind of a similar service. So where you can uh, store your data. So basically, whatever you want to store in S3, you can store it, and it gets converted to an object, to an S3 object. Every kind of data, you can put any kind of data, you can put videos, you can put codes, you can put Excel files, anything. It converts it into a standard format called an S3 object, and then it stores it there, right? Uh, so what it lets you do is, yeah, so you can create different buckets in your S3 service. So here you can see I have two buckets. So basically, yeah, so as Mitul said, you can think of a bucket as a folder. So basically you can say I have two folders. Inside this folder, I just uploaded this model, which you can check the link also in the chat. And how do you upload? You can just do this upload, and you can add files. Now I also have an EC2 instance. Anyone who doesn't know what is an EC2 instance? You can raise your hand or put it in the chat. Yeah. So what is an EC2 instance? So basically, let's say you have your laptop, right? So okay, so many people don't know. So EC2 is also a service by AWS. So if you don't know what is AWS, AWS is Amazon Web Services. So basically, you know what is Amazon? Amazon is a company. It provides some services to us over the web. So that is Amazon Web Services. So what are these services? There are like hundreds of services for different use cases. So if you go here on the homepage, so like these are the services that I have used. So they come under recently visited, and they charge for these services whenever you use them, right? So there's a service called EC2. What is EC2? EC2 stands for Elastic Cloud Compute. So let's say you have your laptop, right? So your laptop is a machine. If you run some code on your laptop, so basically you have your laptop and you are running your code on your machine. So let's say you don't want to use your laptop to run the code. You want to use some other machine, let's say some higher capacity machine, so that your code can run faster, or maybe your laptop does not have enough RAM or enough processing power to run that code. So you want a bigger machine or a better machine. So that's when you can go and create an EC2 instance, and you can define like what kind of machine you want. So if your laptop has, let's say, 8 GB of RAM, but you need 32 GBs of RAM, right? So you can just create an EC2 instance and say that I need 32 GBs of RAM. So just create a machine for me so that I can run my codes over there. So that's what I've done. I have created an EC2 instance. What are its configurations? Let's check view details. This is the instance type. This says t2.small. So this defines my instance. So Amazon has some standard instance names. So I'll just search t2 small and it will tell you what all is its configurations. So you can see t2.small, what it has is, it has one CPU, it has 2 GB RAM, and it also has the prices. So on demand prices, it is $0.023 per hour. So this is basically a machine that I'm renting out. Okay. Any doubts on this? Anyone who is still not clear on this?
So in short, basically think of EC2 as just a computer that you're borrowing, right, from Amazon. It's just that computer has more power to it, right? You can borrow GPU, you can borrow TPU, you can borrow CPU, and so on, right? So you can think of that as an EC2. So so instance basically means that you're just starting that computer and you're using it. That's all it means. Okay. So instance is equal to starting the computer. EC2 is equal to basically renting or borrowing a computer from someone else. Okay. In this case, it's Amazon, and you can do the same thing with the GCP. I think Azure. I never used Azure before, so I'm not entirely sure. But you can also, I think, rent on Azure as well.
So I have started my instance. So what does that mean? I've started my machine. So whenever I'm done with it, what I'll do is I'll just stop instance. So it will shut down my machine so that I won't be charged on it as much as when it is started, right? So I'll still be charged a little on it because I'm still keeping the machine with me, but I've turned it off, so I'll be charged a bit lesser. So I'll just connect to it. So how do you connect to an EC2 instance? You just go to connect. You need a SSH client and you can just put this command in, right? So I've already done that. I'll just show that to you. This is visible.
Yep.
Yeah. So let's just clear it out. So this is basically my EC2 instance. So basically Amazon has some servers over somewhere. So let's say I think it is in North Virginia, and so I'm accessing it remotely. So basically with this terminal, I'm inside that server. So I can do whatever I want now with it because I have rented that server. So let's say you have rented a house, right? So now it is practically yours. You can do anything you want on it, right? So this is basically my server now. This is the IP address. So so I've already put in my codes, right? So let me just show you the Git repo as well. So what I've done is the YOLO v7 repo, I have cloned it here. So this is the YOLO v7 folder. And inside this, there's the direct.py. The other files I've already deleted because I don't need them. All the training files, I don't need it, right? So I've just kept this direct.py. So if you have seen in this one also, so there were many files, right? Train.py, test.py, requirements, etc. Then there's direct.py. I just kept this one and all the relevant folders that it accesses. So other things I've deleted because I don't need them anymore. So what I've done is what is it, this detect.py, right? So it contains a function called detect. What it takes is it takes an optional parameter. We'll not discuss this. What it does is then it basically runs the model on it, right? So I have this main.py. I've created a Streamlit app. Anyone who knows what is Streamlit, or anyone who does not know what is Streamlit? You can type it in the chat. Okay, so Purnima doesn't know. So what is Streamlit, right? So let's just Google what is Streamlit. So it is a way to create some web apps. Yeah, so Manoj is right. So open source app for front end. So how do you create some web apps, right? So that so basically, yeah, it is a front end. So let's see some examples what it can do. There's some examples. Let's see the components. No, gallery. Yeah, let's just see the documentation. Yeah, so this is a Streamlit app. This is called matgpt.streamlit.app. So this whole UI is created from Streamlit, and all the code behind it must be in some language. It can be Python, or it can be any other language that Streamlit supports. The other things you have to code it in that language, but this UI you can create via Streamlit, right? So there is this app. It must be doing something. Basically, it allows you to use GPT-3 to solve math problems. If you see the documentation, get started. It tells you how to install it. Then it tells you how to put in some elements, right? So how do you put text in an app? So it tells you how to do that. You just do st.write or st.title, right? So it tells you how do you use all these elements. How do you put in, how do you show data frames on a UI, right? How do you put some charts, right? Line charts, area charts. How do you put in a chat box, right? So you can create a UI with this. This is called Streamlit. Now I've created a simple Streamlit app. What I've done is I've created this function which fetches my model from S3, right? So I'm giving that my file name is best.pt. I'm just downloading that file from the relevant bucket, right? And I'm running this function. This function will only be run once because I've done it in the cache. So you won't be downloading the model each and every time you are inputting an image. Now what I'm doing is I'm just uploading an image where I want to run the YOLO model, right? So I'm just doing if the uploading file is not none. So basically, if whenever I upload a file, what it will do is it will first save the uploaded file, because how YOLO works is you need an image file to predict. You can't input basically a loaded image in Python, right? So this is the command to detect. So I'm just running Python, then detect.py, giving the weights. What are the weights? My trained model. Whenever you have trained a model and you want to detect something from it or predict something from it, you use your trained model weights, uh, because before training you were using some initial weights or randomized weights. Now you have trained it, so now what do you have? You have some trained weights, right? So these weights will allow you to predict meaningfully. So I've put this best.pt in the weights. This is some parameter that I don't know. It is probably a confidence threshold, so that whenever the confidence is more than 10%, it will show the bounding box. Source, so basically whatever image you want to detect on or predict on. So this is that path of that file. Then this is the parameter view image. So I also want to view the image after this. Then using this os.system, I'll just run this command. After this command is run, I want to show the image, right? So I'll just go to this. So how do I run my Streamlit app? My Streamlit app is hosted on my EC2 instance. So what I'll just do is I'll just first run my Streamlit app. So if you can see, I have this main.py. This is the same main.py that we saw in my GitHub. So I'll just run it. How do you run a Streamlit app? You do Streamlit run. Then
actually, we don't see your terminal or
yeah.
whatever you're running on.
Yeah, let me share that again. Yeah, now.
Okay, good. Yeah.
So what you can see here is I have this folder called object detection end-to-end, and inside it I have this main.py file. This main.py file is the same as the file you saw on the GitHub, right? So I just want to run this file so that I can start my Streamlit app. How do I start my Streamlit app? I just do Streamlit run, then the file name main.py. So let's see what it does. It has hosted the file on this address. So this is the URL, right? So I'll just copy this and show you how it looks. It's visible, right?
Yes.
Yep.
Yeah, so I put this link in the chat as well, so anyone can now access it. It is now publicly available, right? So even so you can, so this is a good thing about EC2. It allows you to host your website as well, right? So you can create a normal website also and host it on your EC2. Just that you'll have to pay for the EC2 instance for the whole machine, right? So this is the app now. What I can do is I can just browse a file, right? I'll just browse this file. It will upload this file, and also you'll be able to see what all is going in the background in this terminal. So this was the terminal. So now it is it first loaded the model, right? Now it is doing some processing. It has so many parameters. What is this, like 36 million parameters, so many gradients, right? So it has done it now. It says done. Now I'll just go back to the Streamlit app. It has given me this output. If you can see it, if I'll just zoom it, it shows me a bus is there with 93% confidence, right? So this is object detection. We just, so what did we just do? Let's just recap. We first got the data set. What was in the data set? There were 4 classes. There was bus, motorcycle, car, and something else, not sure, right? So now you train a YOLO V7 model on that data set. Then you just kept the trained model with you. Then what did I do? I uploaded that trained model on S3. It is not necessary to upload your model on S3, right? You can upload the model anywhere, wherever you can access it, right? Then I made a Streamlit app where I'll just do the prediction. So this is my Streamlit app. I programmed it to take in an image and take in the model, then use those together to create the prediction. So this is all we did. Any questions in this? Anything you want me to repeat?
Was it all clear, or did you guys enjoy it so far?
Is that image uploaded stored in S3? No. So if you just see the code, what it is doing here, it is saving the image locally, right? So this will save the image in the EC2 instance. So wherever this code is being run, it will save the image there.
So think of it as, storing it in memory of your computer, right? It's not saving it anywhere. It's just storing it in the memory of your computer. As soon as the task is done, it will just get rid of it.
So here it is not deleting it. So I don't think I've coded it to delete it yet. So it will, I think, keep the image. So yeah, currently it is keeping the image in the EC2 instance.
So when you use a different image, it doesn't save it, right? It just gets rid of it. It's not stored anywhere in the background, right? Yeah.
So it is stored in the EC2.
Any other questions? Anyone? Otherwise, I'll move on to the portfolio. We're gonna update it later at the end, but I just want to show you guys, what we have created last time, and just to make sure that if you guys are doing it with us, you have the portfolio ready as well. Can we get the link to the repo? Yeah, I'll put in the chat. I'll put it again. Oh, for the GitHub, sure.
This is the link to the repo.
I'll put the Colab notebook link in the chat. You can check it out.
Any questions,
Okay,
anyone?
so if you guys...
Purnima, Suhani, Suhana, Sabarish, Sanjeevni, Sachin, anyone?
And if you guys are going to try this, try it, share it with us on LinkedIn. You can tag us. We'll take a look, and we can give you feedback. So if you guys want to try it.
Yeah, so also tag us, tag me, tag Mithul, tag Data Production, whenever you complete this project, right? And make sure to host it on GitHub as well.
Okay, let's move on. So if you don't have any questions, let's move on to the portfolio. So I'm just going to show you, what we created last time, and we'll update it once you're done with the projects. So this is the portfolio that we're creating. Okay, so if you have missed out, go check it out on our YouTube channel, how to create portfolio. So this is what we have done last time. Okay, so make sure that you update all the content. Here, for instance, I've added the services that we offer as an example, just to show you guys. About, we have updated the about. I didn't bother changing the images, but you can change the images as well. Team, we can add your team and so on and so forth, right? And the plan will be basically, as we do, so we're going to do 3 projects. So we have done 1 today. We'll do 2 more. And we're going to replace all of these default projects with the one that we are going to create, right? So for example, here, we have computer vision object detection project, right? And so this project shows how to detect vehicles in an image. And then you can put a GitHub link. I think I've already done that. Yeah, so you can put your GitHub link, date, service, and so on and so forth. And you can also take a screenshot and then replace this image, right? So I'll walk you through that again next time. Once we finish up all the projects, we'll just update the portfolio. Right now, I can just quickly show you where we can get that link for the portfolio. So if you go to this repo here, all you have to do is fork this repo, right? And you'll have everything from this developer, a bunch of other people who have contributed to this. So we'll get the link and you just have to update things in it, right? So this is the one that we have and we updated a bunch of things in here, right? So for example, you can go to post, you can go to the markdown. So this is the first one, right? So you can see computer vision, object detection project, and then GitHub, data science, and so on and so forth, okay? So we'll update the other ones as well. Do we have a question? Okay. So yeah. So by the end of 3 to 4 sessions, you'll have a portfolio ready to showcase. And also your GitHub. Yeah, don't forget to update your GitHub as well, right? So the other thing we've done last time is basically we showed you how to create this landing page, right? So make sure you create a nice landing page as well, because it gives an impression to the managers, right? Of what you know and things that you have done. Yeah, any questions so far?
So Varish has a question. How will you handle concurrent users? So currently this app does not handle concurrent users. So whenever multiple users are trying to do it on at the same time, it will do it sequentially. So how do you handle concurrent users? You can use different frameworks for it. You can use multi-threading, right? You can also use some queues, queuing mechanism, right? So if you have multiple queues, you can handle it. So you can use Kafka for it. And yeah, if you really have a lot of users, so go to Kubernetes.
Yep, the building an entire ML system, right? So you need the entire pipeline, Kubernetes, all that stuff, right? We just didn't do it because obviously you have to pay for it, right? So, and we don't have that many users. It's just for the demo and how to deploy. There are a lot of things that you could do in here, right? Docker images and all that stuff as well. So you can make use of Docker images. If you're using GCP, Kubernetes, Cloud Run, and all those sort of things. And since you've asked that question, I just want to take that opportunity to show you the mentorship that we have done, and that's where we actually do all this deployment part. But that's not for the computer vision project, but rather for any structured project, right? So we created this end-to-end pipeline where, you know, just like any company, you would have this end-to-end pipeline where a company collects data, stores it in a bunch of places, and the data engineers do their thing, data scientists do their thing, then you have data analysts doing their thing. So all of that we have put together in a single project, and you would use a bunch of tools, right? So GitHub, Jenkins, Airflow, Circle CI, CI/CD, as well as software development lifecycle, coding best practices, and all that stuff, right? So yeah, go check it out. As well, you know, if you're doing machine learning, if you work as a machine learning engineer, you have to try different algorithms, different models. So, you know, you need to use MLflow. So how do you use MLflow, right? And then Jenkins for automation, all that. So yeah, you guys can go check it out. Let us know if you have any questions. I think that's all we have for today. Do you guys have any questions?
Also, I've put in a QR code. If you guys want a refund for this session, you can scan that and fill up the form. Okay, no questions. We'll just wait for let's say 2 minutes.
Thanks everyone for attending. If you don't have any questions, and yeah, tag us, let us know. We can show your portfolio with us, and we'll be happy to share with the LinkedIn network, so you can get some exposure.
We'll repost it if you tag us on LinkedIn.
And then come back next week, right? We'll be doing another data science project next week. You won't be computer vision, but more on the structured side. I'll be doing that session. Haven't decided what, but I'm thinking about marketing, either marketing analytics or recommendation, or like customer journey into, but it'll be mostly related to retail industry because I work in retail. So yeah, don't forget to join us next week. Happy weekend to you too.
Okay, so let's close it.
Yeah.
Thanks.
Okay. Thanks everyone. Have a good night, good day, wherever you're from.